right? But basically, when you see this, you're going to look at these two things. You're going to look at to see the margin of error formula. And I'm using a Z if I have this population standard deviation. I'm using a T if I have a sample standard deviation. So this is your key right here. Am I given this or am I given this? That's an S. Which one am I given? So I have my driving distances in miles. Did I give you this one? Two. Of 30 people. So n is equal, greater than or equal to 30. I don't have to say, assume this is normally distributed. And they're shown below. Assume the population standard deviation. Right away I have this guy. So I know I'm going to use this formula. So my x bar plus or minus e is this one. This is how I should start, just like this. So point estimate, what does a point estimate mean? What did you do for a point estimate? For the population mean, what did you do? Get the mean of your sample, right? Your sample mean is your point estimate, because the only thing we know about is our sample. So we take our sample mean, which is the same as our population mean we've been seeing over the weeks. So we take our sample mean, L1, and can everybody put it in L1 and do this? Everybody can get it in L1? Okay. Don't pull out your population standard deviation from there. It comes from this. This is your population standard deviation. So you're going to find your margin of error. You're going to have to find the ZC for this guy. Remember from the quiz, we separated this. We did inverse norm on this. This is where 95 goes. I need to take half of what's in my tails left over. So I do inverse norm. This is important. Divide by 2. And I get my positive. It's going to give you a negative, but you're going to use the positive. Plug it into your formula, and then build your interval. Can you use your calculator for this? Absolutely. I'm fine with you using your calculator. We good with this? All right. Construct a 95% confidence interval that you found your margin of error. I just had you construct the interval. And if on the test, I give you this and it's ABC. Find me the point estimate. Find me the margin of error. Find me the interval. But you use your calculator. So you're going to have to find the point estimate first, right? Then go find the interval, and then just throw a little arrow backwards that you could use your interval to find your margin of error if you use your calculator. So do you know what I'm saying? So you don't have to go back and use the formula.
For this, I think I rounded differently than you. Like your E is 2.9. For me, I had 3.0. Is that all right? Or no?
As long as your rounding is correct. I don't know what was over here. It's 2.9 what? Okay, so it was added. I rounded to that. Let me just see. Sometimes using your tables is a little different than using your calculator stuff.
I use a calculator. I got 2.9.
You got 2.9? Let me just see what this came out to be. It came out to be this. John, I got this when I did it.
Okay.
So if I'm rounding to one position, this has to be a 9.
All right.
Yeah. I'm going to take points off for rounding, because you guys should know how to round. And so this is what I'm saying. If you did it on your calculator, and you got your interval first, and you don't use your margin of error formula, don't go back and use it. Just take the mean, where was our mean? 9.5, and show me this work. So do 12.4, where I ask for margin of error. You do this minus this, and you get your, whatever this happens to be. What was it, 2.9? You get this. So you don't have to go back and use your formula if you use your calculator. But I obviously have to ask it in that order, because usually you find your margin of error and then your interval. But just go backwards and find it. I don't need you to do the whole formula if, in fact, you don't use it. It's kind of the beauty of the interval. This is the same whether it's a z-score or a t-score. I'm going to find the middle, find my mean, add them up, divide by 2, then subtract my mean from the highest number. That gives me my margin of error. Some of you were off on the quiz. As soon as you find what's in the middle, if you added these two, if you subtracted those two and divided by 2, then you got your margin of error, which is fine. You got your margin of error. Then just go add your margin of error to this guy so that you can get your mean. That's doable. Whichever way you find it. You need to know this one. And did I give you the formula? I think I gave you, if I didn't, I will. Oh yes, I did. It's on your test. You need to know the margin, you need to know the sample size. Now how do I know what I'm looking for? It says determine the minimum survey size. Determine the size. That's the size, the sample size, is my n variable. Go look for the formula that says n equals. If you notice it, we don't use this for the t. We only use this for the z. Only the the z we use this for. I want to be 99% confident. Make sure you put this number into here. Not 99%. If it helps tomorrow, what I'll do is I'll give you the ZC for whatever confidence levels I write on your test. Will that help? And then you don't have to do that whole inverse norm thing. Will that work? All right? So I don't want you to get confused with the TC and the ZC when it comes to that. So if I give you like a 90 or a 95, I'll write those ZCs on the board. In fact, aren't they on the table 4 that I give you? As a matter of fact, they're on this table. When I give you table 4, they're right at the bottom here. Anybody notice that? Your level of confidence is, so that you don't have to do the inverse norm for that. They're right here at the bottom of your table, on table 4. It gives you the popular ones, the 80, 90, 95, 99. So if I give you any others, I will give you the answer. Except if I'm asking you to find it. So in these cases, I will give you those. This one, you just had to find me your critical value. And your test will work the same. When I switch over to this mode, I will ask you for a critical value. Remember your degrees of freedom? Did you not have this one?
No,
You have this one. Remember your degrees of freedom is 1 minus the sample size. Everybody gets a freedom of choice except that last person. And your TC, you can use your inverse T in your calc. It works like your inverse norm, but your table is so much easier. Okay. All right, this guy, did I give you 15? Okay, 15 had you construct your margin of error. That's all you had to do, and then the next part was construct the interval, 19. So you just had to take it and then make an interval out of it. And remember, I don't want you to leave it like this. Don't leave this for me. Either give me this or give me an inequality with a less than sign. Remember, it has to be a less than sign, not a greater than sign. So margin of error, you look that up on your table, plug it in, use your calculator. Are you guys trying the intervals on the calculator? They work so nice. The interval works the nicest. You avoid all of this and you cut right to the chase. But again, I usually get half of my kids using formulas, half using calculator. Did I give you 21? This is the last one. I didn't give you 25? 21? Okay. All right, and a random sample of 28. Now look, this is 28. It has to tell me that this is normally distributed, because n was less than or equal to 30. Follow this statement. In a random sample of 28 sports cars, the average annual fuel cost was $29.29, and the standard deviation was $786. Let me ask you something. What is the subject of this sentence? Think back to English. What is the subject of this sentence? Random sample. The subject is random sample. So everything that I talk about relates to the sample, doesn't it? So notice, this is the sample mean. This is the sample standard deviation. How do I know that? Because Fleur just told me the subject was random sample. So everything relates to the random sample. When you get a population standard deviation, it will say, assume the population standard deviation is. Because there's no place else to put that. So think how you word your English statements. This refers to your sample. So therefore I know I have a TC because I know I have an S. As soon as I know I have my S, I do my TC part. I find my critical value on my table. I plug it into my E. I build my interval. And I can be 90% confident that my population mean will fall between these two numbers. Okay? 95% confident. If I did these, 95%, oh, not 90% of them would fall into that interval. Do you have any questions? I mean, it's pretty basic. Yes?
Can you go over number 8 again?
Number 8, certainly. Do you have any questions from your quiz that you had a chance to look at? Oh, it's stuck in that one part of the board. Okay, so determining sample size. It means if I want to find out a sample and I want to be 99% confident that my margin of error is within 2, there's my margin of error. I want to be within 2 miles from the mean. Within 2 means you can go to the left or to the right, right? Within 2 miles of work. I could either live on this side of work 2 miles away or this side of work 2 miles away. That's your wiggle room. This is your margin of error, which they never say. They say within 2. That's this guy right here. Your ZC is the ZC related to the 99. You only do this for Z-scores, 2.575. Your standard deviation was told us up in the other problems, so it was 8. We plug these in, we square it. We always round up. A lot of you forgot to round up on your quiz, guys. Round up. Sure, is that helpful or what's
So far,
2.575? That came from here. 99% was in here. Because this is a Z-score, not a T. So put this in your inverse norm. You could probably use 2.58. Is that what you use? This one just has the 3 decimals, but whatever one you want to use. Okay, tomorrow's a test.